Okay, so now we're going to talk about biconditional statements. Okay, so basically this is when both P implies Q and Q implies P are true. That's when we have a biconditional statement. And this is usually written, so this is usually written as P if and only if Q. That's the little symbol for if and only if. And this is the shorthand for if and only if, IFF. Okay, so let's go down here. So we have a question, decide if the statement is true or false. Form the converse and decide if the converse is true or false. Okay, so here's the statement that we're going to be looking at. If a square has an area of 25 centimeters squared, then the length of its side is 5 centimeters. Okay, so we have our square, right? So let me try to make it as much of a square as possible. So we have the sides of the length of the square is 5 centimeters, so 5 centimeters, right? 5 centimeters, 5 centimeters. Okay, so if we can remember, the area of a square is equal to side squared, right? So side squared, which is 5 centimeters squared, which is equal to 25 centimeters squared. So we know that if a square has an area of 25 centimeters, then the length of its side must be 5 centimeters. So this statement is true the way it is now. So now let's come up with the converse. So the converse, right? So converse of P implies Q. If you guys can remember, it's Q implies P, right? So the converse would be if, let's see, if a square, the length of a square's side is 5 centimeters, then it has an area of 25 centimeters squared. And we can see that this statement is also true, right? So since both are true, we can write a biconditional statement. So the biconditional statement would be something like this. A squares Oh, a square. Sorry. A square has an area of 25 centimeters squared if and only if, and remember this, the shorthand for this is IFF, if and only if the length of its side is 5 centimeters. Okay? All right, this is all we need to talk about for biconditional statement. Okay.